Doc, reviewing closed pipes for the physics of sound and music. This is the fundamental mode of vibration for a closed pipe. You have a vertical line here to represent no motion, and there's motion over here. When we sketch this in our text, we use a vertical line for no motion and a dash to indicate where you're moving the most. So here we have a displacement node, no motion, and a displacement antinode. Whenever you go from a node to an antinode or vice versa, that's 1/4 of a wavelength. Remember that rule. That's a nice rule to keep in mind. So 1/4 of the wavelength equals L, and that means that one wavelength equals 4L, something that we should memorize for the closed pipe. Then when we come down here to the next mode, you see we add another vertical line, so we have vertical dash, and that gives us 1, 2, 3/4, because each time you go from 1 to its opposite, it's a quarter, so 1/4, 2/4, 3/4, 3/4 of the wavelength equals L, which means 1/4 is L over 3. And if 1/4 is L over 3, one wavelength is 4 of those, so it's 4L over 3, which is easier to just memorize the rule 4L and then 4L divided by 3 and 4L divided by 5. These are the odd numbers. We don't have any even cases. Let's check this next one out. 1, 2, 3, 4, 5. See, 5/4 fitted to L, so that means 5 wavelengths equals 4L. And one wavelength is 4L over 5. So just remember that rule. 4L for the first one, 4L over 3 for the third, 4L over 5 for the fifth, and these are your harmonics. There are no even harmonics. And notice here, one vertical line, a dash. 2 vertical lines, and then the dashes in the other places. 1, 2, 3 vertical lines, and the dashes in between, and always a dash at the end. So there are the rules for the closed pipe. Here is the third harmonic in action, where you have 1, 2 vertical lines, and here is the fifth harmonic in action, 1, 2, 3 vertical lines. And for our chart, it's simple to just remember that all the even ones are gone. So we cross out all the even ones and replace the 2L with 4L, and then we're all finished, because see, we have the same principle, F, 3F, 5F, 7F. You always multiply the frequency column by the harmonic, and we have no even cases, so we always multiply by an odd number. And then here we always divide by the harmonic. So harmonic 3, you divide 4L by 3. For the fifth, you divide 4L by 5. And the intervals are the same idea over here, just whatever the odd ones are. See, unison, you compare the first one with itself, it's 1 to 1. When you go to the third harmonic, it's the same, octave plus a fifth. The seventh we don't worry about. The fifth here is 2 octaves and a third. So very, very simple to get this chart from this other chart for the open pipes by replacing 2L with 4L, crossing out the evens, and you're all set. Notice that the velocity equals the wavelength times the frequency. That's always true. The velocity for these pipes is given by the velocity of the gas, the sound in the gas in the pipe, which at room temperature pressure is 340 meters per second. And notice when you multiply a wavelength with its corresponding frequency, you get the same thing in both cases. See, 2L is the wavelength, F is the frequency, 2L times F is the multiplication. And suppose we check another one, like 2L over 5 times 5F. Well, the 5's cancel, you get 2LF. So all these products here, 2LF when you do the pairs, and here you get 4LF. 4L over 3 times 3F, the 3's cancel, 4LF, and here the 5's will cancel, 4LF. So that's a nice thing to remember. When the frequency goes up, the wavelength goes down, and vice versa.